So today we're actually going to look at the adaptations that things that live in this mesopelagic zone have that allow for them to survive down here where it's weird and strange to us. So we pull these animals up from the mesopelagic zone, like this black scabbard fish, which you can see right here. And we look at them and we think they look really weird. They look kind of slimy. They've got these big bulging eyes. They've got these big sharp teeth and large mouths. And we're like, these things look creepy. And so we look at them like, that's weird. But what's cool about these animals that live here is that they look that way for a reason, and every single feature that you see on them is there designed to allow for them to survive in their habitat. So they're perfectly designed to live in this habitat of the mesopelagic zone. All right, so let's look at this zone and their adaptations. So only about 20% of the food that's available in the epipelagic ever makes it down into the mesopelagic zone. Because there is less food in the mesopelagic zone, you will have fewer animals that can survive down here. So you will not have as abundant or as many animals in this zone as you will in like the epipelagic zone. But remember how we talked about how you get patchiness in the epipelagic zone? So in some areas you get like patches where there's abundant life, and then in other areas where there's like not much going on. So like here you have a bunch of life, and then out here you have like almost nothing. Remember that? Okay, so the patchiness in the epipelagic is actually reflected in the mesopelagic. So in the areas where you have lots of life in the epipelagic, there's going to be more food falling into the mesopelagic in these areas than in other areas. So you're going to get more life here in the mesopelagic than you will here. Does that make sense? So the patchiness that is actually reflected in the mesopelagic zone as well. And most of the characteristics and adaptations that the animals in this area have is for the lack of food, since only 20% ever makes it down. One of those adaptations is that these animals are pretty small. So like we talked about with the fish, between 1 and 4 inches on average, they are pretty small because it takes lots of food and energy to grow to be a large size, so they tend to stay small. Some general adaptations that some of these guys will have down here. Many of them are sit and wait predators. So they're going to be just kind of chilling, hanging out in the water column, waiting for things to come by so that they can eat them. And so they don't know when any of their meals are going to come by. And so they need to be able to eat whatever swims by them. And if that prey item is larger than their mouth, then that's the problem because they can't really eat it. So they have big mouths, so that pretty much whatever swims by, they can eat it because their mouth is large enough to eat that prey item. And also, like, their jaws are big, but then their jaws can also be hinged to open even wider. And they're going to have these big sharp teeth so that when they clamp down on that prey will not get away because those teeth are going to impale the prey item and they won't be able to get away. So they've got these big giant mouths and these big teeth to try and help to capture prey. If they do eat something maybe even that's larger than themselves, their stomachs can adapt to that. They actually have these huge expandable stomachs. They can swallow these things and then their stomachs will expand to fit that giant meal into their stomachs. So you can see that in the picture. So here's the big mouth and then the sharp teeth. And then this is an anglerfish. You can see the male hanging off the female. And then they would have this big expandable stomach to be able to eat whatever comes by. And they're also going to not be picky eaters. They're going to have a very broad diet. They will eat literally anything that comes by. They're not going to be like, I don't like calamari, ew. So if it's a squid that swims by, they're going to eat it. If it's a fish, they're going to eat it. Krill, they're going to eat it. So they will eat whatever. They are not picky. We have two major types of animals. You're going to have migrating animals and non-migrating animals. Migrating animals are going to be what we talked about last cycle briefly. Those are the animals that are going to hide down here during the day and then migrate up to the surface at night to feed. Those are going to be migrating animals. Non-migrating are going to spend their entire lives here in the mesopelagic zone. So they're not going to migrate up to the surface waters to feed. Because they are different, they're going to have different adaptations. So non-migrating fish, well, first of all, copepods and krill are going to eat the detritus, the marine snow that's drifting down from above. The sit and wait predators are going to be a little weird. Okay, so the sit and wait predators basically are trying to survive until their next food comes along, their next source of food comes along. And so that may be a couple months from now, that may be 6 months from now. Basically, they want to try and conserve energy in between their meals so that they can survive to the next meal. So they're going to have all sorts of adaptations in order to reduce the amount of energy that they spend. Here's some of those adaptations. They're going to have flabby, watery flesh instead of like muscles. So muscles take a lot of energy to maintain. One of the reasons why, like, if you work out a lot and you have like big muscles, you're going to be able to eat a lot more is because muscles burn energy. So your metabolism is faster. So they take a lot more energy to maintain. If they're a sit and wait predator, they're literally like not moving really. So they're going to have not very well developed muscles because they don't want to spend the energy in maintaining that muscle mass. Does that make sense? They don't need muscle mass because they're not really swimming. That also means that they're not going to really have strong bones, because the whole purpose of bone is for like muscle to pull on the bone and like move, like your arm, or for a fish move the backbone to allow them to swim. So if they don't have very well developed muscles because they're not going to be swimming, they don't need these big strong bones in order to be able to, for the muscles to pull on for them to swim. So they will have weaker bones because it will take less energy. And those weaker bones are also not as heavy. They will also not have spines and defensive structures, because the whole goal of their life is to pretty much remain neutrally buoyant in the water. So kind of like allow for them to just hang in the water column with as little energy as possible. So if they had spines and defensive structures, that would make them too heavy and they would sink down, and they'd actually have to like swim and like try and maintain the depth at which they're at. So they don't have spines or defensive structures because they would be too heavy. That also means because they don't have spines and defensive structures and they are neutrally buoyant, they don't need a swim bladder. So swim bladders take a lot of energy to maintain, to like keep the right amount of air in there and adjust it and make sure it's just right. So too much energy, they're neutrally buoyant, they don't need it, they don't have it. Does that make sense? Okay. It's kind of weird. This last blank says swimming, if you can tell. Migrating fish are going to be different. They do have to swim. They have to make it up to the surface to feed at night. And then they have to return back to the depths during the day. They do this in order to avoid predators during the day in the epipelagic zone. So they come up when it's dark out. During the day, they spend that time during the day kind of in a zombie-like state, where they're just kind of sleeping, kind of zombie-ish. They're not really moving. They're just trying to conserve energy during the day. And because these guys are swimming, they are going to need well-developed muscles, so they will be much more muscular. They also will then need bones for those muscles to pull on, so they will have stronger, well-developed bones. Because they do have bones and well-developed muscles, they are going to need a swim bladder to offset that weight. And so they will have a swim bladder, but they're swimming from down here in the mesopelagic zone up to the surface. And that's going to be a huge pressure difference for them. So do you remember what we talked about earlier this semester with swim bladders? What happens to swim bladders if you bring a fish up too fast? Yeah, it like explodes, right? That swim bladder expands really fast. So these fish, as they swim up, they're going to need to be able to adjust the volume in that swim bladder very, very, very fast. So they can, or what a lot of them have is they have a swim bladder filled with fat rather than air. Because fat doesn't contract and expand like air does with the pressure differences, but it's also less dense, making the fish more buoyant, which is kind of cool. So they've got a swim bladder filled with fat. So how did we actually discover these migrations?